a function that looks like a fraction and it has an x in both the numerator and the denominator of a fraction. All right. So if we're looking at page 1 of our journal, not journal, packet, all right, we're just going to start easy with just looking at how to simplify rational expressions. Now, since a rational, so it doesn't tell us this, but we're just going to define it anyway. A rational function, and I would write this down, is a function that looks like a fraction. Yes. With an x in both the numerator and denominator. So they technically are functions, meaning that they pass the vertical line test, but they just look weird, all right? But what you will find with rational functions is a lot of their rules are the same as fractions. So knowing those fraction rules are really important. So knowing how to simplify a fraction, knowing how to multiply and divide fractions, adding and subtracting fractions, we're basically going to be doing all of that, but with rational functions over the next couple of days. All right. So the way we're going to start this is we're just going to start with straight up numerical fractions just to review the basic principle. Because if you know how to simplify a numerical fraction, simplifying a rational is not hard. All right, so look at exercise 1, example A. So it wants us to simplify the fraction 18 over 12. Now, you probably learned this back in your upper years of elementary school, lower years of middle school. All right. Can someone raise their hand and tell me how you simplify a fraction? What do you look for? Just simplifying a numerical fraction. Kind of. That's more with adding and subtracting, but you're on the right track. Right. What number that goes into both, or in other words, a GCF, or something to divide them by. All right. So, what number could you absolutely divide both in? It doesn't have to necessarily be the GCF. So, let's go with 3. So, we're going to divide the top and the bottom by 3. So, 3 over 3. So, 18 divided by 3 is what? 6. What's 12 divided by 3? 4. Now, is that fraction fully simplified, or can we keep going? We can keep going. What can I divide into both 6 and 4? 2. So then I'm going to divide both of these by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. Am I done? Yeah. So this will be my simplified fraction. Which, another way to think about this is, let's say I broke 18 and 12 down to their prime factors. All right. So with 18, what are 2 factors of 18? 2 and 9. Which one is prime, meaning they can only be divided by itself in 1? 2. So I'm going to circle that. I can break down 9 again. How can I break down 9? 3 and 3. So these 2 are prime. So I'm going to rewrite 18 in the numerator as 2 times 3 times 3. Now I'm going to break down 12. How can I break down 12? What are 2 factors of 12? 3 and 4. 3 is prime. I can break down 4 into what? 2 and 2. Both of those are prime. So I can put this as 2 times 2 times 3. Now, what happens when you have the same number over itself? What does that equal? So if I have 3 over 3, what does that equal? 1. So could I not say that they cancel each other out because anything times 1 is 1? Isn't that true? That is true. So guess what? If we have the same number being multiplied in the numerator and the denominator, we can cross out the pairs. So I have a 3 in the top and a 3 in the bottom, so I can cross these two out. I have a 2 in the top and a 2 in the bottom, so I can cross this pair out. And then what am I left with? 3 over 2. Is that not exactly what we got in the top part? Isn't that the same as what we got in the top part? Yes. So the reason I bring this up is that's essentially what you're going to be doing with rational functions. You're going to be breaking it down into its factors, meaning you're going to factor the numerator and the denominator, and then you're going to cross out the like factors between the top and the bottom. And then your answer is whatever you're left with. All right? So using that exact same concept, let's look at letter B. Now we have this expression, which this is a rational function. So x squared minus 9 all over 2x plus 6. So before we do anything simplifying wise, we're going to factor both. All right? So let's just factor the numerator first. So x squared minus 9. So you may want that green graphic organizer out for reference. So I would take that out right now. So before we go further, take out that green graphic organizer. You're going to want it for reference because we're about to do a lot of factoring. Yeah. So x squared minus 9. How many terms is in there? 2. Is there a GCF? No. So if it's 2 terms but no GCF, what could it possibly be? A difference of squares. So that means that we have 2 terms that are perfect squares. Is that true? Yes. Because if I took the square root of both, I would get a nice number. So if this is a difference of squares, that means that it would factor as a plus b times a minus b. All right, but we need to figure out what a and b are. So I'm going to take the square root of both terms. So a comes from the x squared. What's the square root of x squared? X. So that's my a value. Square root of 9. 3. So if I take these values and plug it in for a and b in the formula, what's my factors? So just replace a and b up top with the x and the 3. What do you get? X plus 3 and x minus 3. So that's our first set of factors. So I'm over to the side, I'm going to write x plus 3 times x minus 3. Now I'm going to factor the denominator. So I have 2x plus 6. First off, is there a GCF? Yes. What is that GCF? 2. So I'm going to factor out a GCF of 2. So I'm going to divide both terms by 2. So I'm left with 2 times x plus 3. Can I factor that any further? So look at what's in the parentheses. Could I factor x plus 3 any further? No. So we're done. So this is my factored form of the denominator. So I'm going to put 2 times x plus 3. So we just broke down this expression into its prime factors, just like we did with part A right here. So now the simplifying part comes from the same process. We're looking for pairs, one the top, one the denominator. So what can I cross out between the numerator and the denominator? The x plus 3's can go bye-bye. There's one in the top, one in the bottom, so I can cross them out. So what am I left with? Right. So your answer for this is x minus 3 over 2. And that's the simplified version of our original rational. So essentially, all we're doing when we simplify rationals is we're simplifying a fraction, but with letters in it. All right. Not too bad, right? So like I said, knowing how to factor plays a big part in this unit, because if you can factor it correctly, the actual simplifying is really easy. Any questions on that? All right, let's do another example. So again, the key process here is that we're simplifying. Numerator and denominator must be factored, and only common factors in both cancel each other out. All right. So if you had two of the same values in the numerator, but there's not a same value in the denominator, you still can't cross it out. It has to be one in the numerator, one in the denominator, one for one to cross it out. All right. So now let's simplify some monomials. So that means there's no real factoring. It's just all one thing going on here. So to help us with this, I'm going to separate both of these terms into I'm just going to expand them. So are there any factors of 3 besides 3 and 1? No, so I'm just going to write 3. How many x's do I have in x to the 5th? 5, so I'm going to write 5 x's. How many y's do I have in y to the 6th? 6. Now, the reason I'm doing this, and you'll see in just a second, but it'll make it a little bit easier to see. Now, how can I rewrite 6 into 2 factors? Besides 1 and 6? 3 and 2. So I'm going to do 2 times 3. How many x's are there next to the 8th? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many y's? 3. Now guess what? To get my answer, I'm just going to do my cross out method. So I have a 3 in the top, 3 in the bottom, cross them out. I have 5 x's in the top, 5 x's, at least 5 x's in the bottom, so I'll cross out 5 x's between the top and the bottom. And then I'll cross out 3 y's between the top and the bottom. And I'm left with a 2, 3 y's on top, 3 x's on the bottom. So in other words, it'll be y times y times y over 2 times x times x times x. Which if I combine all the y's and x's together, 3 y's being multiplied together is the same thing as what? Y cubed. And then we have 2 times, if we have 3 x's, what's that equivalent to? X cubed. And guess what? You just simplified those two binomials. Now, what's the other way that you could have done that problem without having to write all that out? You learned this back in Math 2 and Math 3. Not Math 3, Math 1. Right, you can just subtract the exponents. Since we're doing monomials, you could also do the exponent rules, meaning you subtract exponents of like bases. And I always do the biggest minus the smallest, and then I put it back where the biggest was. And you could have done the same thing. So let's try another one. Let's try letter C. So letter C, I'm just going to do the exponent rule, which remember the exponent rule is called the quotient rule. meaning you can subtract exponents of like bases when dividing. All right. So let's just do my simplifying. So I'm going to draw my fraction bar. I'm going to simplify my numbers first. So 7 over 21. What fraction does 7 over 21 simplify down to? So think about what could you divide from both 7 and 21 to simplify that fraction? 7. So if I have 7 over 21 and I divide 7 from the top and the bottom, what do I get? 1 over 3. So I have 1 here, 3 here. Now, I then have, oh no, I then have x cubed over x to the 5th. Those are like bases. So in reality, I can subtract the two exponents. Now, what I like to do is I like to do biggest exponent minus the smallest, and then I put my answer back where the biggest was. So I'm going to do x to the 5 minus 3, which is what? X squared. And then where would I put that x squared, in the numerator or denominator? Denominator, because that's where my bigger one was. So I'm going to put the x squared down there. And then lastly, I have my y's. So with your y's, if you don't have an exponent, what's your unspoken exponent? 1. So if I do biggest minus smallest, I have y to the 8th minus 1, which is what? Y to the 7th. And where does it go? Numerator, denominator? Denominator. So y to the 7th. So if I clean this up a little bit to look nice, my final answer will be 1, because that's what I have left in my numerator, over 3x squared y to the 7th. So if you like separating into the factors, you can do that. You'll get the exact same answer as if you use the quotient rule. But that's only if you're dividing monomials or one-termed polynomials, meaning there's no pluses or minuses. If there's pluses or minuses, that's when we have to use our factoring rules. Any questions on dividing monomials by each other? Speak now, forever hold your peace. All right. So let's look at some actual simplifying rational expressions. So similar to what we did with example 1. So look at exercise 4, letter A. So again, first thing you want to do is factor the numerator and the denominator. So let's factor the numerator first of letter A. So first off, what do I always ask myself if I have a what? A GCF. All right. Do I have a GCF here for x squared plus 5x minus 14? No. So I move on to my factoring. So it's a trinomial. So I know I'm going to have to do big X somewhere. A times C still goes on top. B goes on the bottom. I'm looking for where it multiplies to A, or multiplies to A times C, adds to B. So what is A times C here if I label them A, B, C? Don't forget there's an unspoken 1 here. What's A times C? Negative 14. And what's my B value? 5. So I need two factors of negative 14 that add to 5. Now, if I'm multiplying to a negative number, what are the signs of my factors going to be? If you're multiplying to a negative number, what's the only combination of signs that will always give you a negative number if you multiply them? A positive and a negative. So that means that one of my numbers is going to be positive, and the other one's going to be negative. So I'm just going to write one negative sign in, just so I know that one of them has to be negative. So let's just list some factors of 14. What are some factors of 14? 2 and 7 and 1 and 14. Now, since one of those numbers has to be negative, that means that we're actually subtracting to get positive 5, because one of the numbers has to be negative. Which set of factors actually would end up subtracting to give us 5? 7 and 2. And like Landon says, since we're subtracting to get positive 5, the smaller of the two numbers is the negative one. So I'm going to put 2 here and 7 here. Now, since our A value is 1, we can just do the shortcut. So once you get your two factors, that means you can write it as x minus 2, because that's our first factor, and then x plus 7, because that's our second factor. And we're done. Yes. Yeah. But remember, you can only do that if your A value is 1. If it's not 1, you have to do your reverse box like we did in the warm-up. So that's my first set of factors. I have x minus 2 over x plus 7. Now I need to figure out how to factor the denominator. So if I'm factoring the denominator, x squared minus 4, how do I factor x squared minus 4? What does it look like to you guys? It's a difference of squares. So since this is a difference of squares, that means it's going to factor to a plus b, a minus b, where we have to find a and b by taking a square root of our two terms. So I'm going to take a square root of both. What's the square root of x squared? X. Square root of 4. 2. So, given a and b, if we plug them back into the formula, what are my two factors? X plus 2, x minus 2, which I would write up here. So x plus 2, x minus 2. So now my rational is split into its factors. So now I can start doing some crossing out. What is the only factor that matches up in both the numerator and the denominator? X minus 2. So because I have one in the numerator, one in the denominator, they're gone. 1 for 1. So I'm left with what? X plus 7 over x plus 2. And that would give me my answer. Any questions on letter B? I mean letter A, sorry. All right. Let's try letter B. Actually, try letter B on your own. It's not too bad. So try letter B on your own. Just take a minute, try letter B on your own. If you get stuck, let me know. I'll give you a hint. Letter B is very similar to the very first one that we did. So the one on the front. So just to kind of help you out, guys, the numerator is a what? It's a difference of squares, because both of these are perfect squares. So you're going to factor the top like a difference of squares. The bottom, you're just going to have a GCF. All right? So that should help. Now, try it now. Thumbs up if you're ready. Okay, I'll give you guys another minute. When Landa gets back here. All right, guys. I see the gears turn, but I also see some steam coming out of y'all's ears, so let's talk about it. All right. So, with this one, I said the top part can be factored as a difference of squares. So how do I factor a difference of squares? I do what first? Maddie? Right, we take the square root of both terms to get our a value and b value. What's the square root of 4x squared? 2x. Good. Square root of 4 is 2. Square root of x squared is x. That's how you go about that. What's the square root of 1? 1. So, now that I know what a and b is, what's my two factors? 2x plus 1, 2x minus 1. That's all you got to do. Now, the denominator is a little bit different because even though it's a two-term polynomial or a binomial, is that a difference of squares? No, because 10 and 5 are not perfect squares, neither is x. However, they do have what in common? So that binomial has a what? What do you always look for first when you factor? A GCF, or a greatest common factor. There is a GCF, and what is that GCF? 5. So I have 5 on the outside. Divide both terms by 5. 10 divided by 5 is 2. And then there's still an x there, so 2x. 5 divided by 5 is 1, and since it's negative, it remains negative 1. So that should have been what you got when you factored the top and the bottom. Now, what can I cross out between the two? Right, we have a 2x minus 1 up top and a 2x minus 1 on the bottom. Since we have both of those, we can get rid of them. So what am I left with? 2x plus 1 all over 5. And that should have been your answer. Any questions on that one? All right. So here's what I'm going to do. We're still not done with notes, but I can see that you guys are kind of going brain dead a little bit. So what we're going to do is we're going to take a 5-minute break. I'm going to set a timer. So for 5 minutes, if you need to use the restroom, you can go ahead. If you need to stand up and just stretch your legs, that's fine. If you need to get water, go ahead. But you need to be back in this classroom by the time this timer goes off. All right? So go ahead and do that. All right, guys, up and at 'em. Gonna get back to it. All right, so I've been doing that with my freshmen for the past couple days. So if that's something that you guys may want, we can do it that way too, just to kind of give you guys a brain break for a little bit. Um, so let's get back into the swing of things and finish up these notes for today. All right, so let's look at example C. So we're still doing the same thing, but we're going to do this one together because of that top polynomial. All right. So the bottom one we can go ahead and factor because what's special about the bottom or the denominator? It's another difference of squares. All right. Meaning what? How do I factor it? Square root both to get a and b. What's the square root of x squared? X. Square root of 16. 4. So what is x squared minus 16 factored to? X plus 4, x minus 4. All right, so that's the denominator. The numerator is going to take a bit more legwork because, first off, is there a GCF in the numerator? Yes, no, maybe? No, there is not. What kills us is that 3. All right, 14 and 8 have a GCF, but the 3 does not. It's not included in that GCF. So We have to do the method where we do our big X. And since it's not, this A value is not equal to 1, that means we're going to have to either do a reverse box or the grouping method to factor it. So I'm going to label my terms A, B, C. So what goes on top of my big X? A times C, which is what? 24. So again, we did A times C, that gave us 24. What goes on the bottom of the X? 14, or your B value. Now, I'm looking for two terms that multiply to 24 but add to 14. So let's list some factors of 24. So someone tell me a set of factors for 24. 2 and 12. What's another one? 8 and 3. What else? So what else do we got? 4 and 6, yeah. What else? Say that again. 1 and 24. And I'm pretty sure that's it. All right. Which set could potentially add up to 14? 2 and 12. 2 plus 12 is 14. So those are our factors we're going with. So I'm going to put 2 here, 12 here. And then remember, we're going to put x's after them because that's what's going to replace the 14x. So do you guys want me to do a reverse box or do you want me to do the grouping? What do you guys want me to do? Grouping? All right, I'll do grouping. So if I want to do grouping, I want to use my original. So that would be 3x squared. And I'm replacing the 14x. So I'm going to do plus 2x, plus 12x, and then plus 8. Now I'm going to group the first and last two terms together. So these are together, these are together. And then I'm going to find my GCFs of the individual groups. What's my GCF of my first group? Just x. 3 and 2, the way you can go about this is 3 and 2 don't have a GCF besides 1. But x squared and x have at least one x in common, thus the GCF is x. So I'm going to divide both of these by x. So I have x on the outside times, what's 3x squared divided by x? So in other words, if I took 1x away from x squared, what am I left with? Just 3x. Then what's 2x divided by x? Just plus 2. So that's my first set. My second set, what's my GCF for my second set of, or my second group? It is 4. So I'm going to divide both of these by 4. I have 4 on the outside. Then what? So what's 12 divided by 4? 3. So I still have the x, so I'm going to bring that down. What's 8 divided by 4? 2. So that's plus 2. Now, we know we did our grouping right if both of my bubbles are exactly the same. Are they both exactly the same? Yes. By the way, if you hear me say bubbles, that's what I say when I mean a set of parentheses. All right? So just know that if I say bubble, I just mean what's in the set of parentheses. Now, since they're the same, that means we're going to bring our two GCFs down to one factor. So what would that factor be if I bring the two GCFs down together? X plus 4. And then I bring down one of my common bubbles, which is 3x plus 2. So that would be what the numerator is factored to. So I have x plus 4 times 3x plus 2. So once I get here, I can start the crossing out process. What's the only factor that I can cross out between the top and the bottom? X plus 4. We have both of those in common, so they go bye-bye. What am I left with? I don't want to know. What am I left with? Good. 3x plus 2 all over x minus 4. Not too bad, right, guys? The hardest part is really the factoring.
I think it's just really long.
Yeah, trust me, rational functions, they're long problems. So just, prepare yourself for this unit because this is actually the shorter side of the problems.
What are we doing tomorrow?
Multiplying, dividing. All right, last thing that I want to mention is sometimes you're not technically given the same factors, but you can finagle them to give you the same factors. Because if I have x minus y and y minus x, all right? So if I look at example A, what's 9 minus 6? 3. What's 6 minus 9? Negative 3. If I simplify that, what do I get? Negative 1. 15 minus 3 is what? 3 minus 15. Negative 12. Simplify, it's negative 1. So, a minus b simplified is still a minus b. What could I factor out of b minus a to make it so I have a minus b? So if I rewrote this is the same thing as negative a plus b. All right, all I did was just switch the terms but keep the signs, which you can totally do. You can do that based off of the commutative property. What could I factor out of the denominator to make the bottom term a minus b? So in other words, I want to change the signs. So all I got to do is take out a what? A negative 1. So if I factor out a negative 1, I got a minus b over negative 1 times a minus b. Which if I cross out, a minus b is gone. I'm left with what? So I'm left with 1 over negative 1, because there's nothing left in the numerator, which simplifies to what? Negative 1. So what I'm trying to get across here is if you have pretty much the same terms, but the signs are switched, you can finagle it or manipulate it to make it so that they have the same signs by taking out a negative 1. All right, you can totally do that. That is totally fair and within the rules to do. All right, because sometimes that you do have to end up doing that. So last example we're going to do, look at exercise 6. This goes along with what we just talked about in exercise 5. How do I factor the numerator? The numerator has a what? What do I look for first? GCF. Does it have a GCF? Yes. What is it? 2. So this has a GCF of 2. So I have 2 all over. 2x divided by 2 is x. Negative 10 divided by 2 is negative 5. Now, how do I factor the denominator? It's a difference of squares because 25 and x squared are both perfect squares. So I'm going to take the square root of both terms to get a and b. So square root of 25 is what? 5. So that's my a value. Square root of x squared is what? X. So what are my two factors? Nope. Wrong order. Right. So if 5 is a, you have to put 5 first. So 5 plus x times 5 minus x. Now, when you get to this, as it stands right now, we cannot cross anything out. Your gut instinct may be to cross out this x minus 5 and the 5 minus x. But if I rewrote those two terms, so I'm just going to write that up top. So x minus 5 over, I'm just going to switch the places, negative x plus 5. All I did was rewrite 5 minus x by switching the two terms but keeping the signs. Are those the same? No, they're not the same thing. The top part of x is not negative. The 5 is not positive in the numerator. So they are not the same. But we can manipulate it to be the same. What can I do to the denominator to make it the same? Take out a negative 1. So I can make this x minus 5 over negative 1 x minus 5. So in other words, down here, I'm going to rewrite this as 2 over x minus 5 times, I'm going to have a negative 1 out here, and I'm going to write the x minus 5 as negative 5 minus x. Or if you want, just write it as x minus 5, because we already did it. And then 5 plus x is the same thing as what if I just switch the terms? X plus 5, right? Yeah, it's just x plus 5. Because the negative 1 only affects this x minus 5. That's where we took it out of, so we don't have to take the negative 1 out of this term. We just got to take it out of this one. So now what can I cross out? X minus 5, x minus 5. So what am I left with? So 2 over negative 1 times x plus 5. Now, with a negative 1, which of these answer choices do you think is the equivalent of this right here? Number 1. Why is number 1 the equivalent? Well, what's 2 divided by negative 1? Negative 2. So this is the same. If I simplified this fraction, 2 divided by negative 1 is negative 2 over x plus 5. So that's why it's number 1. So just know, if you don't have like terms or like factors, but they're very, very similar, the only difference is the signs are flopped, take a negative 1 out of one of the factors to make it the same. All right? Any questions on that? All right, so we're going to stop there for today. We'll do multiplying and dividing tomorrow. So hold on to that yellow graphic organizer because you'll be using that for notes tomorrow. So, couple of things. There is a delta math that covers this, but you're not going to be able to do all of it just yet. You'll just be able to do the simplifying. So you can work on that if you'd like. Another thing is that